Hello, today I am here to explain you exercise 1.2 perhaps of Bindal maths. In the previous class we have done that the root 2, root 3, root 5, similarly root 7 are all irrational numbers. Using all this, we will prove these are irrational. So number 1. Process is almost similar only, but we can use this now. These are irrational is already known to you. So number 1, let 3 plus root 2, 3 plus root 2 be rational. On the contrary, we assume that this is rational. So therefore, 3 plus root 2 can be written in the form of p by q, where p and q are co-prime integers with q not equal to 0. Now, what is root 2 equal to? P plus root 2 can be p plus 3 will come down as 3q. Now see here, what you have? What are p and q? P and q are integers. See, if p and q are integers, if q is integer, then 3q is also integer. So integer by integer, non-zero integer. This is non-zero. Q is not equal to 0 will be rational. So therefore, p by 3q is rational. And this is equal to this. If this is rational, so this is also rational. Therefore, root 2 is rational. This is the contradiction, because we have already proved that root 2 is irrational. Sorry. This contradicts the fact that root 2 is irrational. This contradiction, why, Rajal, you know, understood? Because you assume that this is rational. So your assumption is not correct. So this is not rational. That's why it is irrational. Therefore, 3 plus root 2 is irrational. This much only. Now, similarly, you can do number 2. So I will omit this. This push. Okay, number 2 now we will start. Let 3 plus 2 root 5 be rational. Now, therefore, 3 plus 2 root 5 can be written in the form of p by q, where p and q are integers and q is not equal to 0. Now, you have almost the process. Everything will transport to the right side except the root 1, the radical sign 1. So this can be very clearly 2 root 5 equal to p by q minus 3 transpose this side. Then 2 root 5 equal to q is the LCM. What we will get? P minus 3q. Then what is root 5 equal to p minus 3q by twice q. Now see here. What is p and q? Since p and q are integers. Now see here, if p is integers, q is integer, then 3q is also integer. Then p minus 3q is also integer. So this is numerator integer. Q is integer, then twice q is also integer. So integer by integer is rational. So that's why what is clear that this part is rational. The p minus 3q by twice q is rational. And this is equal to this. If this is rational, this will also should be rational, no? Therefore, root 5 is rational. And we have already known to us that root 5 is not rational, it is irrational. This is the contradiction. This contradicts the fact that root 5 is irrational. Irrational. This contradiction is because our assumptions were not correct. Therefore, 3 plus 2 root 5 is not rational. If not rational, therefore 3 plus 2 root 5, if not rational, then irrational, is irrational. Clear? This is a little bit different. This both are this only. Same thing only. So I am doing number 4 here. You will try number 3. I am doing number 4 now. Okay. So 3 and 4 same thing only. 4, if you understood 4, 3 you can do yourself. So number 4. Process is almost same only, little bit simplification is different. So let on the contrary assume that this is rational. Let root 5 plus root 3 be rational. Therefore root 5 plus root 3 can be p by q, where p and q are integers and q is not equal to 0. Anyone transpose that side. Root 5 is equal to what we'll get? P by q minus root 3. Now squaring on both sides. What will get here? 5. This is a minus b whole square will give you a square minus twice ab. So 2 root 3 p by q. Understood this? 2 into a into b plus b square, that is 3. Okay. Now what always you are doing, you always try to put the root 1 to the left side. So transpose this side. 2 root 3 p by q one side and everything that side. Okay. 3 minus 5 minus p square by q square. Okay. So what you will get? 2 root 3 p by q is equal to minus 2 minus p square by q square. 2 root 3 p by q. Can you take LCM q square? So minus 2 q square minus p square. See, this and this two can be cancelled, okay? Because q is not equal to 0 is known to you. What is the final? 2 root 3 p is equal to, transpose q to this side. What you will get? Minus 2q minus p square q. Okay, this is to cancel only, sorry. This is q only. Q square is cancelled. Sorry. So what you have got actually? This q was cancelled only, no? And this is power 2 is also cancelled. So what is left? Put root 3 on one side. Root 3 equal to minus twice q square minus p square by twice p will come here and q already here, twice pq. Now see here, since p and q are integers, therefore minus 2q square minus p square by twice pq is rational. Oh, this is integer, integer minus integer, this is integer by integer rational, and this is equal to this. So therefore root 3 is rational. And this is the contradiction. This contradicts the fact that root 3 is irrational. You know that root 3 is rational, but you are getting rational. This is because of your assumption. Assume this rational is wrong. Therefore, root 5 plus root 3 is not rational. If not rational, then what? Irrational only. Therefore, root 5 plus root 3 is irrational. Exactly similar way you can do this. Almost same only. Okay. This also I want to explain you, but you can do yourself also, just like this only. But okay, if you want, I can explain you. Very easy, you are getting it. Some are not, few sums were not in the exercise. So little bit different type I want to give you, other similar type you can do yourself only. Okay, number 5 also. Let 2 root 3 minus 1 be rational. Almost similar, you understood already. So therefore 2 root 3 minus 1 equal to p by, comparatively easier than this. So 2 root 3 equal to p by q plus 1. 2 root 3, simplify first this here. Q is the LCM, so what do we get? P plus q. Then you know roots, only root should be in the left side, so root 3. P plus q, this 2 will be here, twice q. Same thing, since p and q are integers, therefore p plus q by twice q is rational. Now see, this is equal to this and this is rational, so this should be rational also. Therefore root 3 is rational. And this is a contradiction because already you know that root 3 is not rational. This contradicts the fact that root 3 is irrational. And this contradiction that because of our wrong assumption. Therefore 2 root 3 minus 1 is not rational. If not rational, therefore irrational. 2 root 3 minus 1 is irrational. This type of any sum we can do like this. Process is this only, little bit simplification, lengthy. So that's all. This type of sum is there. In some next exercise we will do. In next class I will explain you next exercise.